Got like a double infinity loop here. We've got it on Logitech, and we've got it on this presentation here. Okay, cool. Let me see. Bring up my notes and make sure I don't steer you guys too wrong. Okay, so midterm exam Redux. Let's go ahead and take a look at this. So it split itself into 3 different sections. There were 2 questions in the first one and then 1 in each of the other ones. And unlike the exams we did last semester, I'm having you guys do just like a complete lab test this time, which I would love to do some of them as multiple choice, because then, of course, the classroom can kind of grade that part for me. But I felt like this was better. We'll see how things go in the next week or so, and then we'll decide what to do for the final exam. But I have a feeling it's going to be something like this again. So anyway, the first question had to do with the first normal form, and the second one, the second/third normal form, depending on how you want to think of it. And then the second section was to create an EER diagram, and I gave instructions about that. And then there were some SQL scripts to run for the last section here. So let's go ahead and do these one at a time. I've got the instructions up in front of me. So I'm going to jump over to here. And let me see, I got a preview going here. Okay, so hopefully you guys can see that okay. What's that? So this was the data that I gave you to start with.
We could only see the Google Classroom.
Oh, really?
Yeah. Not sure if you meant to share the whole screen.
Thank you. I did mean to. Appreciate that. I'm going to stop presenting. I guess I did just do the window the first time. Let me do the whole thing this time. All right, how's that now?
Yeah, good.
Excellent. Thank you for letting me know. I appreciate that. I'd hate to ramble on for half an hour without you guys seeing anything. All right, so the first question is basically just to put this into first normal form. And a hint, you do not need to separate the data into multiple tables to do this. And I know from experience that looking at something like this, some students are immediately going to try to split this into multiple tables. Yes, you don't need to do that. You almost never need to do that to solve for first normal form. In fact, I can't think of an example where you would have to off the top of my head. But what's going to happen here, let me go ahead and copy this whole thing. So let's see, including the title of our table here, weeks, chapters. So you might recognize some of the chapter titles from the book. And we're going to start off with first normal form here. Let me try that with a 1 instead of an I. That would make a little more sense. So the first normal form just states that data in fields cannot be non-scalar, which means that it can't be a collection, more or less. I'm sure there's a more technical definition than that, but that's what it basically comes down to. You cannot have a couple of values that can be separated by a comma here. That means there's 2 different values there. They need to be separated so that you don't have to rely on some kind of script in order to split them apart at runtime. You don't want to have to do that. So you cannot extend this way. You cannot start creating more columns for these guys because you never know how many columns you're going to have to add. And it's a duplicate of the column anyway, so it doesn't solve first normal form. So we expand it downward instead. So wherever you've got scalar data like this, sorry, non-scalar data, you split it up into 2 rows instead of 2 columns. So I'm going to take this and I'm going to copy it, and I'm going to paste. And on this one, I'm just going to have Chapter 10, which is how to design a database. And on this one, I'm just going to have 11, which is how to create databases and tables. And then I got to do the same thing down here, right? Because in week 4, there's also a collection. So copy and paste it. So you got 2 of them. And in this first one, we're going to get to just chapter 18, which is how to secure a database. And then this one, we'll do chapter 19, which is the other one. how to back up and restore a database. Okay, so we split this up, and so we no longer have the collections anywhere. Now there's some weird stuff happening here. If this is our primary key, we now have like duplicate values. They're no longer unique values and so on. But that's okay. If all we're tasked is to solve for first normal form, then we've just done it. And we're good to go. So, and you guys did good on this one. Overall, you did very well on this one. So I'm going to do the next one, which is, I asked for a second normal form. I felt like it might be a little confusing to skip and ask for third normal form, even though we talked about it on that Monday beforehand. But anyway, they're so close to being the same thing that you can almost think of them simultaneously. Second normal form says that everything has to depend on a primary key, and third normal form says everything must depend only on a primary key. So here's the thing, is we've got week and chapter title, right? And we've got some data that's not dependent on a primary key, such as it is. If we call this thing the primary key, it's not really, because it's got non-unique values. But okay, we could say that the chapters depend on that, but what about the chapter title? The chapter title seems like it depends more on chapter, right? Chapter 10, how to design a database, goes with chapter 10. It doesn't, that goes with week 1, it goes with that more so. So this is where we need to kind of split this up onto a couple of different tables. And the one that we're going to do, and by the way, this one, I knew this was going to be tough on you guys, even though we talked about it and you guys read about it and we did it in week 1 and everything. This is the most abstract stuff that we do in either of these two classes, is data normalization. And it's, it's a big topic. I was not hard on the points on this one. If you got any work, no one got it perfect, but if anyone got close to what I was looking for, then I gave you like a 4.5 out of 5. Like normally what I do is, like on the SQL portions of exams and so on, I look for problems, and wherever there's a problem, either the instructions weren't followed or an error comes up when I try to run the SQL script or when I try to execute it. Whenever something like that happens, I take off half a point from whatever little section it's in, but I did not do that here. I didn't do that here at all. I just, like, if you got close, 4.5. If you made some kind of effort that was kind of going in the right direction, you got a 4. And then if you didn't submit anything, then you might have gotten a little bit less than that. Just for future reference, it's always better to turn something than nothing in. And that's not just for me. I think that's for any instructor I've ever had. So bear that in mind going forward. So let's see. Yeah, this is the first normal form, and we need to get this into second normal form. So here's where we're going to split this into two tables, and I think I gave you that as a hint. Is that, okay, so here, yeah, do split it into a couple of tables. So I'm going to copy this whole table so that we've got a couple of them, and I'm just going to call one, if this whole thing is weeks and chapters, I'm going to call one chapters and the other one weeks, at least to start with, right? And then so chapters, basically what we do is we get rid of all the weak information so that we have a primary key of the chapter number, and then the chapter title that way can depend only on that primary key. So I'm just getting rid of all of the weak information here, leaving the chapter, the chapter number and the chapter title. Okay, now
I'm having one of those moments where now that you spell it out, it seems so simple and obvious. But when I was taking the exam, I had no idea how to split this.
Yeah, that happens in tests. It happens all the time, and I recognize that. I understand that. It's like, oh, well, if I knew that's what you meant, I could have done that. Yeah, that happens all the time. I try to be aware of that when I'm grading tests, because I remember taking tests and how it is. Okay, so we got the chapter into one table here. Now we're not quite done yet. A lot of you left it here, but then if you do, like, what's this row about, right? Null and null. We can't have null in the primary key. And anyway, there's no data here at all, so let's get rid of that. You definitely wanted to do that. And then after that, it's up to you if you wanted to put these in order. It's not really critical or anything, but I probably would, just for fun. I didn't take any points off for not putting it in order, because in a database, it doesn't really matter. There we go. Get them into order. I guess conceptually, I would just want to get them in order just to be clear that they're no longer dependent on like the ordering of the weeks here. It's got its own order and they're independent of each other, but again, it doesn't really matter. Okay, so this one is going to be just week and chapter, but now that we've got a chapters table, you guys know what I'm probably going to want to call this column here. I'm not going to want to call it chapter anymore. Anybody have an idea what I want to call this? It's going to be referencing the other table. It's going to be referencing the chapters table. So what should I call it? Well, normally what we've done so far is we would have an ID column in chapters, and we would call this like chapters ID, right? So this is chapters parenthesis ID, and then this is chapters ID. So you could call it this, and I'd be happy with that. But really, it doesn't make sense because we don't have something called ID here. We have something called chapter, the column. You could change this to ID, and I wouldn't complain about that. That would be fine. Or just call this chapters chapter. I know that might seem a little bit redundant, but it actually isn't. This is not an unreasonable identifier in MySQL. So either one of those would be perfectly fine. Chapters chapter, or if that's too confusing, go ahead and do chapters ID and then just change the name of this to ID. And then we can go ahead and get rid of this third column that has the chapter name and then the chapter title, because that's stored up here, right? We don't need that twice. It's redundant. Now this one, some people like removed this, got rid of week 3 altogether, and that I would not do, because there still is a week 3, right? Week 3 still exists in the class. It's just that it doesn't have any, like, we didn't do a chapter lesson in it, that's all. So I would definitely leave that one in there with just a null value for the chapter's ID. And then, boom, we're good to go. So if you got this far, then perfect score, but I don't think anyone made it quite this far. I'm actually going to go back and look again. I had to go over these a little bit quickly, but I will check again. And if you're looking over your own work and you think, you know what, Bispo, I did do this, you're trying to cost me points here, let me know about it and I'll take another look for sure. Now, I said there's a bit of unstated extra credit to do with this one, and that's another thing. That's another reason I want to go back and look for it and see if anybody caught. I don't think anybody did, but it's possible. The thing is, this now conforms to third normal form, but it doesn't really still conform to second normal form. Why? Because when you say that everything has to depend on an ID, you're really talking about an ID with unique values, right? Otherwise, it doesn't make any sense. This is not a unique value primary key here under week, because it's got duplicate values, like there's a 1 and a 1, and there's a 4 and a 4, and so on. So basically what we need to do is you need to have some kind of like a compound key, or just add a different primary key. So one way to do this, let me copy this thing. So this is for the extra credit now. And it was just this one table. Like the chapters table, this is fine. It's got an ID column. It's got like unique values in here. It's not auto-incrementing, but it does have unique values. This table is perfect. There's nothing to complain about with this table at all. It's this one, the weeks. And so one way that you could fix it is by adding an ID column to this, like so, or rather by like so. And then it would be an auto-incrementing key to the left of everything over here, 1, 2, 3, 4, 5, 6, 7. And then each of those would have the week and then the chapter ID and so on. That is one way to solve it. I don't like that personally. I would prefer to see a solution more like what invoice line items does with the AP database, which is to create a compound key so that you've got the week and then something else to indicate. So let me, how do you want to say it? Like, so okay, so invoice line items had an invoice ID and a line items ID, or a line items column, or whatever. So you would have like invoice 1, and then invoice 1 might have several line items in it, like 1, 2, 3, and 4. So that was a compound primary key, where you had like invoice ID 1, line item 1, invoice ID 1, line item 2, invoice line item 1, line item 3, and so on. And you would repeat that invoice ID for as many line items as you had. So I think that's what I would like to see with this one. I think that instead of putting an ID column, or at the beginning, I would probably put week and subject here, as in like subject number 1 and subject number 2, and so on. So in between these two, let me just do the first two to start us off here. So yeah, this is week 1, subject 1. Week 1, subject 2. So these are the two subjects that happen in week 1. And then this is now a primary key, a composite primary key. So these two columns taken together become the primary key instead of just a single column. So this one would be week 2, subject 1. There's only 1 in week 2. 1 in week 3, even though there's nothing in it. Week 4 has a couple, like this. So week 4 is subject 1, week 4 is subject 2, and then week 5 has 1, which is subject 1. And then the chapter's ID, which references the chapters table up here. And I think this would be an elegant solution to it. But like I said, either one would work. You could put an ID column before everything, or I think this works better. And then I would probably name this something different, either weeks subjects maybe. Oops. Or maybe even just subjects. I'm not sure. I guess might as well, if I'm not sure, I should keep it as simple as possible, so I'll just call it subjects. So this all kind of implies that there is an Uber table somewhere, which this was totally beyond like what I asked for, even with extra credit. But like, yeah, I mean, you kind of imagine that there's another table somewhere that's referring to all of these, where you've got ID and then like subjects week, referencing this column here, and then maybe like I don't know, like an assignments, another table that has assignments in it, lectures or lesson plans or whatever, or something like that. So in addition to having like the subjects thing, you would also have another table for assignments for each week. You would have another table for lectures for each week, and they would all be kind of brought together under this big Uber table here. But that's all like abstracting it to the next level. You didn't need to think about that at all. Okay, so then we're done with section 1. Any questions about that, about first normal form or what we did down here, the extra credit? All right, cool. Let's go on to the second one. So, or question 3. Use MySQL Workbench to create an EER diagram for a database that stores information about artists and galleries in which their work is displayed. That might be a little bit fun. So I'm going to hop on over to MySQL Workbench. I'll go ahead and close this out. Okay, there we go. So to create an EER diagram in MySQL Workbench, go to the Home tab, and then go down to the second item in the pipe. And this is for models, so I'm going to go ahead and create plus here to create a model, and then double click on add diagram to create the EER diagram. And here we go, we've got a little bit of our diagram panel here. So so what do we got to do? So artists and galleries, that sounds like two tables to me. Each artist must have a first name and a last name. Okay, cool. So we know what the must-have stuff means, right? That means that those are columns that you got to put into that table, and that this should be not null. Each artist can display in multiple galleries. That sounds like a one-to-many from artists to galleries. Each gallery must have a name and a zip code, so there's that must-have language. That means that these are columns that have to exist in galleries table, and they have to have not null on them. And then each gallery can display multiple artists, which is a one-to-many going in the other direction. So let's make the tables first. So this guy right here, and by the way, I think I said that you could actually, oh no, that was for the project. The project I said you can make the EER diagram anything you want, but For this one, I did ask for MySQL Workbench in particular. Okay, so table 1, I'm going to double click on it to edit, and I'm going to call this artists. And you know your first job is to get an ID in there. And if you just go click on auto increment here, AI, it automatically does the rest of it for you. It assumes that this is the primary key, that it's an integer type, and that it's primary key, and it's not nullable. And so, okay, so each artist must have a last name and a first name. So cool, let's go ahead and put them in here. So I'm going to put in last name, I can spell, and variable character, that works, make that not nullable. And then first name, double click on those. And then same thing, varchar 45, not nullable. And that'll get us started off for this table. So close this off and drop down the indexes, and here we go. Super simple table. Next up, I'm going to jump to the third criterion. Each gallery must have a name and a zip code. You guys know I like to start with the must-haves. Kind of gets the ball rolling here. So this is going to be galleries. Start off with your ID, int not null. There we go, primary key, not null, AI, int. And then a name and a zip code. Now, you guys know a name is one of those things that kind of starts showing up as like maybe a reserved word in MySQL. So it wouldn't be completely out of line to go ahead and call it gallery name or something like that if you happen to remember that. Otherwise, name is fine. Not null, because it must have. And then we need a zip code. Apparently, that's all the contact information we need for these guys is a zip code. After that, we can figure it out. Okay, ID, gallery name, zip code. That'll get us started. Here we go, drop down the indexes. Okay, so the next step is those two criteria that I kind of glossed over here. Each artist can display in multiple galleries, and each gallery can display multiple artists. When you see that kind of language where it looks like a one-to-many going one direction and a one-to-many going the other direction, that means that you're talking about a many-to-many relationship. And it's not the easiest thing in the world to code necessarily in MySQL. There's a few lines of code you have to remember, but if you remember how, it actually is uber easy here in MySQL Workbench. It's the N to M entity, the relationship icon down here. Tap on that to activate it. Click on one. In this case, it doesn't matter which one you get first, and then click on the other one, and it creates a junction table for you with galleries ID pointing to this one, artist ID pointing to this one. If I drop down the indexes, then it sees, yeah, I got the primary. This is a case where this is a compound primary key, by the way, where both of these together form the key for each one. Either one by itself would not work, but at the same time, they're both foreign keys pointing to other tables. So it does have a primary key. When I hover over a primary key, you can see it highlights both of them up here, just as this one just gets the one. So there's both of them, and then these are the two foreign keys down here. You don't have to rename or anything. At this point, you're good to go. If you hit Control-S for save, it'll offer to save this as a MWB file. I won't go ahead and do it, but your job is done on this portion of it. So, questions about the EER diagram portion of the midterm exam? Okay, cool. I'll leave this open for the nonce. I'm going to pop over here to our local instance, and let's go ahead and close these guys. Do I need that? I don't need that. Go away. Okay, so this has to do with DDL language, right? The stuff that you guys learned in Chapter 11 about creating databases, creating tables, creating indexes, altering tables, things like that, where instead of writing queries that perform actions on the data of the table, you're performing actions on the table itself or the database or what have you. So I had you create a new database. And I gave a little bit of extra credit for remembering to do this. Drop database if exists. And I think about half of you got that in, something like that. I guess I better look at my instructions here. Let's see. Create a database named family. So first of all, drop database of exists family. Okay. And you can run this. I'll go ahead and clear this stuff out. There we go. And then create database family. That's simple enough. So this little bit here was extra credit because it didn't really matter all that much. But this next part I did require that you do because creating the database does not select the database over here. In fact, it doesn't even show up here unless you refresh it. So it's critical that you do use family. And just run that. So I don't take off a half point for that, but still that's critical when you run a script like this. Otherwise, it's all too easy when you're creating tables and so on. Because that's the next step of this, right? After you create a database, you're going to be creating the tables to go in the database. If I hadn't run this line, BookTrader was the one that was still selected, and I started creating tables, it would start adding them to BookTrader. Like it would not respect the fact that I just created a database here and assume that that's the one I meant. So I don't normally make a deal of it, but in this case, it's actually important for the scripts that follow. Okay, so we created a database. Create a table in the database named parents. So create table parents and give it the following, in addition to the primary key, following columns: surname, varchar 45, and given name, varchar 45. Okay, so your first job is to get the primary key in there. Int not null, auto increment, primary key. A couple of you are doing the primary key explicitly down there in its own clause, and that's perfectly fine if you want to do it that way. This way I've just been doing for years because it's easy and it works. Okay, so we got the ID, and then so we need surname, and that's going to be varchar. If you did a certain, like if you did varchar 50 instead, I don't care. It's fine. The only reason I'm picking 45 is because that's what the models seem to enjoy here when you're creating an ER diagram. I've kind of latched onto that now. And then what do we need here? We need given name. So again, variable character. And variable because some people might be named Bob and other people might have significantly longer names than that. Okay, I think this is all we need for parents, so I'm going to go ahead and run that. It never hurts to do a select all, which you can either do here or you can refresh the navigator and go to, there's family down here. Close this off. And you can go to the tables and there's parents, and if you just tap on this little icon here, it shows the table. There we go, and there it is, and that's what it should look like. All right, cool. Next up, create a table named children. Sorry, I'll try to type slower here. Okay, in children, we need, in addition to the primary key, given name, date of birth, and parents ID, varchar 45, date, and int. Okay, so this is going to have an ID. You could just copy and paste the other one if you wanted to. But at this point, I wouldn't recommend doing it. I would recommend typing this over and over again until it's just in your fingers. Okay, so given name. And this again, you could copy from upstairs, varchar 45. And this time, in addition to the given name, we need a date of birth with a data type date. And then finally, parents ID. Now you guys know what this is supposed to be, right? Parents ID, if you didn't know it, I put it down there explicitly. Give the column parents ID a foreign ID, or sorry, a foreign key constraint that references parents ID column. You should know as soon as you see this and you've got a table called parents, like you know what to do here, you know. But I told you anyway, okay? So here I will do it explicitly. I will give it a constraint. And let's give it a name here. Children, K, parents. And then this is going to be a foreign key. And it's going to references, parents, the ID column, like this. And what am I missing? Oh, I'm missing the column here. I need to give it the column parents ID. So let me put that in parentheses here, parents ID. And then let's put that down there. There we go. That looks better. You got to do it. This is why it's handy to have them name the same thing. Parents ID, just slightly different punctuation to go with first. This one's a little more complex than the parents table, so I'm just going to do a quick check over here. Given name, date of birth, date, parents ID. See, that needs a data type. It's going to be an int. And probably want this to be not null. And a constraint. Give the constraint the name, foreign key, parents ID, references parents ID. And boom, looks fine. I can refresh over here and double check my columns at least. So this is children. ID, given name, date of birth, blah, blah, blah. So good. So just so you know, there are easier ways of doing this. You could do something as simple as this. And it'll do just about the same thing. And I would accept this. I wouldn't take any points off if you did something this simple. Or something in between, like this. That would be fine too. So what's the difference? Well, if you do an actual constraint here, then you get to name the constraint. You get to give it its own name separate from the column name, and that just gives you more flexibility down the road. Does it matter right now for what we're doing right here in this class? No, it doesn't. Nothing that we're doing in this class is really going to depend on us having named constraints. So if you did something like this, perfectly fine. Okay, last bit here. Alter the table parents. So this is one of the other things that was in chapter. This is all, by the way, all the SQL stuff is from chapter 11. That was the only chapter that I referenced for the SQL scripts here. So alter the table parents, rename given name to mom name. And I tried to give you guys like the answers in the questions. So like create a table, right? And so on. And here we're going to be altering a table. You gotta tell it what table. We're going to alter parents. And you can either do this as two different scripts or as a single script with comma, with separating two clauses. Either way is fine. So first of all, it says to rename given name to pop name. So this is a rename column. Now some of you figured out a solution, actually a few of you figured out a solution where it was a modify column, and in the modify column you change the name of it as well as whatever other information it needed. But that was fine. I mean, I was happy that you guys found another solution to it. But the rename column is like the most straightforward to rename a column. So you do a rename column parents. Wait a second. Rename column. What is it? What was it called here? Given name, right? We need to change given name to mom name. There we go. To mom name, like so. And that works. And then do another one here. Alter table parents. And this time we're going to add a new column called pop name. Also bar chart 49. Oh, sorry, 45. So add column pop name and varchar 45. And let's see, did we give a not null on the given name? No, we did not. So I'm not going to bother with that here either. So we'll go ahead and do that here. And then once again, you go ahead and select everything from parents just to check and see how it went. Surname, mom name, pop name. Yeah, we're happy. And at that point, you're done. So this is the SQL portion of the midterm exam. So creating a database, extra credit for dropping it first, using it, and then creating table parents and children, altering table parents, alter table parents. Oh, by the way, here's how you do it as a single, oops, what the heck just happened? Copy. So if you wanted to do it as a single statement, you certainly could just do that. Single statement, two modifications or two alterations separated by a comma in between. Either way works. Okay, and that is the Redux for the midterm exam. Any questions about the whole shebang here? All right, let's go ahead and stop this recording.